When I first examined the data on 3IATLAS, I immediately understood something extraordinary was unfolding. This was not an ordinary comet. This was not just another icy traveler orbiting our sun. This object did not belong here. I have spent my life studying the universe, black holes, string theory, parallel universes, hyperspace, but every so often a discovery comes along that forces even me to pause. 3IATLAS was one of those moments. The designation itself tells a story. The 3I means it is the third confirmed interstellar object ever detected in human history. Third, out of billions of years of cosmic evolution. That number alone tells us how young our technological civilization truly is. For billions of years, interstellar debris has likely drifted through our solar system unnoticed. Silent messengers from distant stars passing through like ghosts in the night. But now, for the first time, I can say with confidence we are no longer blind. When I analyzed its trajectory, the numbers were unmistakable. Its velocity exceeded the escape velocity of the sun. That means it is not gravitationally bound to our solar system. It is a visitor, and visitors change everything. In astrophysics, motion never lies. The mathematics was crystal clear. 3IATLAS originated from outside our stellar neighborhood. Somewhere around another star, perhaps thousands of light years away, a violent gravitational event flung this object into interstellar space. For millions, perhaps billions of years, it wandered through the dark vacuum between stars. Imagine that journey. No sunlight, no warmth, just the faint glow of distant galaxies. This object may be older than complex life on Earth. It may have formed when our planet was still molten. It could have witnessed supernova explosions, passed through interstellar gas clouds, even drifted near the gravitational fields of massive stars. When I think about 3IATLAS, I am not just looking at a rock. I am looking at history. A fossil from another solar system. One of the most surprising facts is this interstellar objects like 3IATLAS are likely not rare at all. The galaxy is a violent place. When planetary systems form, giant planets shift and migrate. Their gravity slingshots smaller bodies into deep space. Entire solar systems eject debris constantly. This means the Milky Way is not empty between stars. It is filled with fragments of shattered worlds. What surprises me most is not that we found 3IATLAS. What surprises me is that we have only now developed the instruments sensitive enough to detect them. This marks a turning point in human civilization. For centuries, astronomy was about observing our own system. Then we discovered exoplanets. Then we mapped the cosmic microwave background. And now we are physically detecting objects that were born around other stars. This is the beginning of interstellar archaeology. For the first time, I can hold, at least through spectral analysis, a piece of matter that formed somewhere else in the galaxy. And this opens a profound possibility. Could such objects carry organic molecules? Could they transport the building blocks of life? There is a hypothesis known as panspermia. The idea that life, or at least its ingredients, can travel between star systems aboard comets and asteroids. 3IATLAS does not prove this idea, but it makes it scientifically discussable. And that alone is revolutionary. Because once an idea moves from speculation to measurable science, civilization changes. When I look at 3IATLAS, I do not just see a comet. I see a bridge between solar systems, a reminder that our sun is not isolated, we are part of a galactic network. And this is only the first of 10 astonishing facts. Jisur Hamza Khan Ab main Part 2 is the first person Michio Kaku voice main continue Kar Rahahun, cinematic scientific powerful. The 10 most surprising facts about 3IATLAS Part 2 that speed defies the logic of our solar system. When I calculated the velocity of 3IATLAS, I immediately realized we were dealing with something extraordinary. In physics, numbers do not exaggerate. Numbers do not speculate. Numbers tell the truth. And the truth was astonishing. Every object that belongs to our solar system follows a predictable gravitational dance. Planets orbit the sun in elegant ellipses. Comets swing inward and then return bound by gravity like invisible chains. But 3IATLAS was not dancing, it was escaping. Its velocity was so high that even before it approached the inner solar system, I knew one thing with certainty: this object was never captured by our sun. To understand how shocking this is, consider the concept of escape velocity. Escape velocity is the speed required for an object to break free from a gravitational field. For Earth, it is about 11 kilometers per second. For the sun, it is far greater. When I examined the data, 3IATLAS was already exceeding the sun's gravitational grip. That means it was not orbiting. It was passing through, like a bullet through air. And this leads to one of the most surprising facts. 3IATLAS is moving at speeds that could only be achieved by powerful gravitational slingshots in another star system. Somewhere in the distant past, something dramatic happened. Perhaps a giant planet, larger than Jupiter, shifted its orbit. Perhaps two massive bodies interacted chaotically. In that violent gravitational ballet, this object was flung outward with enormous energy. Once ejected, it became a rogue traveler, For millions of years, it drifted between stars at incredible velocity. In interstellar space, there is almost no friction, no atmosphere, no resistance. Once accelerated, an object simply keeps going, and that is precisely what 3IATLAS has been doing. When I project its trajectory backward, I see a line stretching deep into the Milky Way. It did not originate nearby. It likely traveled vast distances across the galactic disk. This is not just motion, this is galactic motion, and here is what truly fascinates me: at such high speeds, even tiny deviations matter. A slight gravitational tug from a star, a molecular cloud, or even dark matter concentrations could alter its path over millions of years. Which means its journey is a cosmic story written by gravity itself. I often describe gravity as the sculptor of the universe. It shapes galaxies, bends light, creates black holes. In the case of 3IATLAS, gravity turned a simple fragment of ice and rock into an interstellar messenger. But the speed tells us something deeper. It tells us that planetary systems are unstable. We once believed solar systems were neat and orderly, like clockwork. But modern astrophysics has shattered that illusion. Young planetary systems are chaotic. Massive planets migrate, orbits shift, collisions occur. Entire worlds can be thrown into deep space. 3IATLAS is evidence of that violence. It is a survivor of cosmic chaos. And when I imagine its journey, I see something poetic. A fragment of another star system, born in turbulence, traveling alone through the vast darkness, only to briefly cross paths with humanity, a species that has just begun to understand the cosmos. Its speed is not just a number. It is a statement. It tells me that the universe is dynamic, energetic, and interconnected. We are not isolated islands. We are participants in a galactic ecosystem where matter is constantly exchanged. Stars shed material, planets eject debris, interstellar space becomes a highway, and 3IATLAS is racing along that highway. One day in the future, I believe humanity will not just observe such objects. We will intercept them. We will land probes on them. We will analyze their isotopes directly. And when that day comes, we will be studying matter that formed around another star without leaving our own solar system. That is the power of speed. Because speed is not just motion. Speed is destiny. And 3IATLAS reminds me that the universe is far more fluid than we once imagined. This is only fact number 2. When I examine an object like 3IATLAS, I am not merely looking at a distant streak of light. I am decoding a chemical fingerprint from another star system. Every atom tells a story. Every spectral line is a message. Using spectroscopy, I break incoming light into its components, like a prism turning white light into a rainbow. Hidden within that rainbow are signatures of elements: hydrogen, carbon, oxygen, metals, complex compounds. And here is where things become truly fascinating. The composition of 3IATLAS may not perfectly match the chemistry of typical comets formed in our solar system. That possibility alone is revolutionary. For decades, I have studied how stars manufacture elements through nuclear fusion. Hydrogen becomes helium, helium becomes carbon. In massive stars, heavier elements are forged and later scattered into space by supernova explosions. Every solar system forms from a slightly different chemical recipe. That means 3IATLAS carries the chemical memory of another stellar nursery. When I analyze its light, I am essentially asking, what kind of star gave birth to this object? Was it a star richer in heavy elements than our Sun? Was it older? Was it born in a denser region of the galaxy? Even slight variations in isotopic ratios, different versions of the same element, can reveal an entirely different origin story. And this is what excites me most. Because chemistry is not random, it is structured by astrophysical history. If 3IATLAS contains unusual ratios of carbon compounds, it may suggest formation in a colder or more radiation-intense environment than our Kuiper belt. If its volatile materials behave differently as it approaches the Sun, that tells me something about how tightly those molecules were bound. In short, its behavior under sunlight becomes an experiment. One of the most surprising possibilities is that interstellar objects may preserve pristine material from the earliest days of their star systems. Over billions of years, planets undergo geological change, atmospheres evolve, surfaces are reshaped. But small icy bodies often remain relatively untouched. They are time capsules, frozen archives of cosmic chemistry. 3IATLAS might contain organic molecules that formed before Earth even existed. Let that sink in. Long before life emerged on our planet, chemistry was already experimenting elsewhere in the galaxy. If I detect complex carbon chains, precursors to amino acids, it strengthens the argument that the building blocks of life are common in the universe. And if such molecules exist around other stars, then life itself may not be rare. This is why composition matters. Because composition bridges physics and biology. It connects stars to cells. I often describe the human body as stardust that became conscious. The carbon in our DNA was forged inside ancient stars. The iron in our blood was created in supernova explosions. If 3IATLAS carries similar building blocks, then it is not foreign to us. It is distant family. Another surprising fact is this interstellar space is not chemically sterile. For many years, scientists believed the void between stars was empty, but modern radio telescopes reveal complex organic molecules drifting in molecular clouds. This means 3IATLAS has likely traveled through chemically rich regions, possibly collecting or altering compounds along its journey. Radiation from cosmic rays could have modified its surface chemistry over millions of years. Ultraviolet light from passing stars may have triggered reactions. In that sense, it is not just a fossil, it is a dynamic laboratory. And when I consider that this object survived such an immense journey without disintegrating, I realize something profound. The galaxy is more interconnected than we ever imagined. Material is constantly exchanged. Star systems are not isolated islands. They are part of a cosmic recycling system. 3IATLAS is evidence of that grand exchange. And as I study its composition, I am reminded that chemistry is the universal language of the cosmos. No matter where you go in the universe, hydrogen behaves the same way. Carbon forms the same bonds. Physics does not change, which means the ingredients for life, for planets, for complexity, are likely universal. That is the deeper implication. 3IATLAS may be telling us that the universe has been conducting chemical experiments long before humanity existed. And perhaps, somewhere else, chemistry also crossed the threshold into biology. This is only fact number 3. G. Sir Hamzaka and Ab Main Part 4, Continue Karahahun, Puri Terra First, Person Michio Kaku Voice Main Cinematic Visionary Deeply Scientific Tone Ki Sath. The 10 most surprising facts about 3IATLAS Part 4. It may be older than our solar system. When I contemplate the age of 3IATLAS, I am forced to confront the immensity of cosmic time. Our solar system is approximately 4.6 billion years old. Earth formed shortly after. Life emerged perhaps 3.5 to 4 billion years ago. Human civilization, a mere blink. But 3IATLAS may predate all of that. That possibility is staggering. To understand why, I must step back and consider how planetary systems form. Stars are born inside vast clouds of gas and dust. As gravity pulls material inward, a rotating disk forms around the newborn star. Within that disk, particles collide, merge, and slowly grow into planetesimals, the building blocks of planets. But this process is violent. Not all material becomes planets. Much of it is ejected. When giant planets like Jupiter form, their immense gravity disrupts smaller bodies. Some are sent crashing inward. Others are hurled outward at tremendous speeds. And once an object escapes its parent star's gravitational grip, it becomes a permanent wanderer. Now imagine this scenario happening billions of years before our sun even ignited. The Milky Way itself is over 13 billion years old. Stars have been forming and dying for eons. Entire generations of solar systems have come and gone. 3IATLAS could have been born around a star that formed billions of years before our sun existed. That means it may have been traveling through interstellar space for a time span almost impossible to comprehend. Long before Earth cooled, long before oceans formed, long before the first cell divided, this object may have already been drifting between the stars. When I consider this, I realize something profound. 3IATLAS is not just a visitor from another place, it may be a visitor from another era. In astrophysics, we use isotopic dating to determine age. Ratios of certain radioactive elements decay at predictable rates. If we ever obtain direct samples from an interstellar object like this, we could measure its formation age precisely. And if that age predates our solar system, it would confirm that we are holding a fragment of a cosmic ancestor. That would make 3IATLAS a time capsule from a previous generation of stars. This is deeply humbling, because it reminds me that our sun is not special in time. It is part of a long lineage. Stars are born, stars live, stars die, and their remnants seed future systems. The atoms in my body were forged in ancient stars that exploded long before our sun formed. If 3IATLAS predates our solar system, then it carries atoms that witnessed even earlier cosmic epochs. It may have drifted past supernova explosions. It may have passed through regions shaped by galactic collisions. It may have orbited the center of the Milky Way multiple times. Each orbit around the galactic core takes roughly 225 million years. If it has been traveling for billions of years, it could have completed many such revolutions. That means 3IATLAS has journeyed around the galaxy more times than Earth has existed. Think about that scale. When I study cosmology, I often remind myself that time is not something we merely measure. It is something the universe embodies. Rocks on Earth preserve geological history. Ice cores preserve climate history. But interstellar objects preserve galactic history. 3IATLAS may contain microscopic clues about conditions in the early Milky Way. Perhaps it formed in a region richer in heavy elements. Perhaps it emerged from a star cluster long since dispersed. Perhaps its parent star has already gone supernova, leaving behind a neutron star or black hole. If that is the case, then this object is a relic of a system that no longer exists. It outlived its own star. That idea is astonishing. It transforms 3IATLAS from a simple comet into a survivor, a remnant of cosmic evolution. One of the most surprising implications is this: interstellar objects may be older than many planetary surfaces in our own solar system. Earth constantly renews itself through plate tectonics. Mars shows signs of ancient erosion, but an object drifting in interstellar space experiences almost no geological change. In the vacuum, time moves differently. There is no atmosphere, no weather, no erosion. Only radiation and cold darkness. In that sense, 3IATLAS may be one of the most ancient untouched objects ever observed. And when I realize that humanity has detected it at precisely this moment in our technological history, I feel a sense of cosmic timing. For billions of years, it wandered unseen. And now, just as we develop powerful telescopes and sky surveys, it crosses our path. This is not destiny. This is probability meeting preparedness. The universe has always been sending these messengers. Only now are we capable of receiving them. If 3IATLAS truly predates our solar system, then studying it is like opening a chapter of the Milky Way written long before Earth existed. And that realization changes how I see our place in the cosmos. We are not at the beginning of the story, we are somewhere in the middle, and 3IATLAS is whispering about the chapters that came before us. This is only fact number 4. Ji Sir Hamza Khan, Ab Main Part 5 Continue Kar Raha Hoon. First person Michio Kaku Voice Main Deep Visionary Scientifically Grounded Tone Ki Seth. 10 most surprising facts about 3IATLAS Part 5. Could it carry the seeds of life? When I look at 3IATLAS, I do not simply see ice and rock, I see possibility. One of the most profound questions I have explored throughout my career is this: how did life begin? On Earth, life appeared relatively quickly after our planet cooled. Within a few 100 million years, simple organisms were already thriving in the oceans. That rapid emergence suggests something important. Either life forms easily under the right conditions, or its ingredients were delivered. Comets and asteroids have long been suspected of carrying organic molecules, complex carbon-based compounds that are essential for life. We have already detected amino acids in meteorites that landed on Earth. That means the chemistry of life does not require biology to begin. It can emerge in space. Now consider this: if organic molecules can form in our solar system, then they can form in other solar systems as well. And if planetary systems constantly eject material into interstellar space, then the galaxy may be continuously exchanging the raw ingredients of life. This concept is known as panspermia, the idea that life, or at least prebiotic chemistry, can travel between star systems aboard comets and asteroids. For many years, this idea was considered speculative. But interstellar objects like 3IATLAS bring it into the realm of serious scientific discussion. Because now we have physical evidence that material from one star system can enter another. When I analyze the spectrum of 3IATLAS, I search for carbon chains, hydrocarbons, and other organic compounds. If I detect them, and the early data suggests that complex chemistry may indeed be present, then I must consider a radical possibility. The building blocks of life may be widespread across the Milky Way. Think about what that means. Life on Earth may not be a miracle isolated to one planet. It may be part of a larger galactic process. 3IATLAS may have formed in a distant system where planets once orbited a young star. Perhaps that system had oceans. Perhaps it had chemistry evolving toward biology. Even if life never formed there, the chemical seeds may have existed. Over billions of years, cosmic radiation could have altered its surface molecules, creating even more complex compounds. Ultraviolet light can drive chemical reactions. Cosmic rays can trigger molecular transformations. Interstellar space is not dead, it is chemically active. One of the most surprising facts is this: organic molecules are surprisingly resilient. Experiments have shown that certain microorganisms can survive extreme radiation, deep freezing, and even the vacuum of space for limited periods. If microscopic life were shielded within rock or ice, it might endure longer than we once thought possible. I am not claiming that 3IATLAS carries living organisms. There is no evidence of that, but the chemistry alone is revolutionary, because chemistry is the precursor to biology. If complex organic molecules are common on interstellar objects, then the galaxy is not sterile, it is fertile. In that case, life may not need to originate independently on every world. It may spread. Consider Earth's own history. During its early years, heavy bombardment by comets and asteroids was frequent. These impacts delivered water and organic compounds. Our oceans themselves may partially owe their existence to icy bodies from space. Now imagine expanding that process to a galactic scale. Planetary systems eject debris. Some of that debris drifts for millions of years. Eventually, it enters another system. Some fragments collide with young planets, and chemistry begins again. This creates a cosmic chain reaction. Life begets chemistry, chemistry begets life. The galaxy becomes a network of biological potential. When I think about 3IATLAS in this context, I realize it represents more than astronomy, it represents connection. The carbon in my cells may have once traveled between stars before becoming part of Earth. That idea is not mystical, it is astrophysical. Every atom heavier than hydrogen was forged in stars, and stars continuously recycle their material. 3IATLAS is a visible reminder of that recycling. It tells me that the boundary between solar systems is permeable. Matter crosses it, possibly even life. And here is what truly amazes me: for billions of years, this exchange may have been happening silently. Only now are we intelligent enough to notice. If future missions intercept an interstellar object and directly analyze its chemistry, we may discover molecular structures that push the limits of our understanding. Perhaps we will find unfamiliar combinations of organic compounds. Perhaps we will confirm that the ingredients for life are universal. Either way, 3IATLAS forces me to confront a powerful conclusion: the universe may be biologically friendly, not necessarily filled with advanced civilizations, but chemically prepared, ready, waiting. And if that is true, then life on Earth is not an isolated accident, it is part of a cosmic pattern. This is only fact number 5. When I think about 3IATLAS, one question immediately dominates my mind: what if I could reach it? For the first time in human history, we are not merely observing an interstellar object. We are technologically close to touching one. In the past, such objects would have passed unnoticed. Even if we had seen them, we would have lacked the capability to respond. But today, the equation is changing. Rockets are more powerful. Detection systems are faster. Artificial intelligence can analyze trajectories within minutes. Space agencies can design rapid response missions. If I calculate its path early enough, interception becomes a matter of engineering, not imagination. That realization is astonishing, because intercepting 3IATLAS would mean physically examining matter born around another star. Without leaving our solar system, I would not need to travel light years. The universe has brought a sample to us. The challenge, however, is speed. Interstellar objects move extremely fast relative to the Sun. To intercept one, a spacecraft must accelerate quickly and match its trajectory. Traditional chemical rockets may struggle with such rapid response missions. But advanced propulsion concepts could change that. Ion drives, solar sails, nuclear thermal propulsion, even laser-driven light sails. A technology I have often discussed when imagining interstellar travel. If a high-powered laser array on Earth were to push a lightweight sail, it could accelerate a probe to extraordinary speeds. In principle, such a system could chase down an object like 3IATLAS. And if I managed to land even a small probe on its surface, the scientific rewards would be historic. I could measure isotopic ratios directly, analyze its mineral structure, study its organic chemistry in detail, perhaps even drill beneath its surface to access materials shielded from radiation for billions of years. This would not just be planetary science. It would be interstellar science. One of the most surprising facts about 3IATLAS is this: it represents a shortcut to studying other star systems. Normally, to analyze another planetary system directly, I would need to send spacecraft across light years, a journey that would take tens of thousands of years with current technology. But interstellar objects bring fragments of those systems to us. They are natural messengers, cosmic couriers. And if I can intercept them, I gain access to foreign material without the impossibility of interstellar travel. This shifts the paradigm of space exploration. Instead of waiting centuries to visit another star, I can study samples delivered by the galaxy itself. There is also a strategic lesson here. The detection window for such objects is short. They appear suddenly, they move quickly, they depart forever. That means humanity must develop rapid response capabilities. If I detect 3IATLAS early, I must be prepared immediately. This requires global coordination, fast funding, advanced propulsion research, a new mindset. For decades, space missions have taken years of planning. Interstellar interception demands agility, speed, precision, and that urgency may accelerate innovation. Every time a new class of object is discovered, civilization evolves. When I first studied black holes, they were theoretical. Now we photograph them. When gravitational waves were predicted, they seemed undetectable. Now we measure them routinely. Interstellar objects are the next frontier. 3IATLAS is not just a scientific curiosity, it is a catalyst. If I successfully intercept such an object in the future, it will mark the beginning of interstellar material science. And once that door opens, it never closes, because more will come, statistically many more. As telescope surveys improve, I expect detections to increase dramatically. Perhaps dozens per decade, maybe hundreds. At that point, interception becomes not a rare opportunity, but a new branch of astronomy. And here is what excites me most. The technology developed to chase interstellar objects will also advance our ability to travel beyond the solar system. Every challenge solved brings us closer to the stars. 3IATLAS is, in a sense, a rehearsal, a preview, a small step toward humanity becoming an interstellar species. When I look at it, I do not see a distant rock, I see a test. A challenge issued by the universe itself. Are we ready? Because the cosmos has begun knocking at our door. This is only fact number 6. Jaiser Hamzakana main part 7 continue Kar Raha Hun. First person Michio Kaku voice main intense thought provoking scientific depth ki sat. The 10 most surprising facts about 3IATLAS part 7 is it truly natural or something stranger? Whenever an interstellar object enters our solar system, one provocative question inevitably arises in my mind, is it entirely natural? Or could it be something more? As a physicist, I begin with the simplest explanation. Nature is extraordinarily creative. Gravity, radiation, and chaos can produce structures that appear almost engineered. But science advances by asking bold questions and then testing them ruthlessly. When the first interstellar object was detected years ago, its unusual shape and acceleration sparked intense debate. That experience taught me something important. The universe is under no obligation to behave according to our expectations. So when I examine 3IATLAS, I analyze its motion with precision. Does it accelerate in ways consistent with outgassing? The release of vapor as ice heats near the sun. Does its brightness fluctuate predictably as it rotates? Is its trajectory fully explained by gravitational mechanics? So far, the data points strongly toward a natural origin. But the mere fact that we must even ask the question is extraordinary. Because for the first time in history, humanity is observing objects that originated beyond our stellar system. That opens the door to possibilities once confined to science fiction. Could an advanced civilization send probes disguised as comets? Could artificial objects drift between stars, silent and undetectable until they pass near a sun? From a purely physical standpoint, interstellar travel is not forbidden by the laws of physics. It is difficult, extremely difficult, but not impossible. If a civilization millions of years older than ours existed somewhere in the galaxy, its technological capabilities might dwarf our own. It might deploy autonomous probes designed to explore distant systems. Such probes could travel for eons, and they might not look like spacecraft. They might resemble natural objects. Now, let me be clear. There is absolutely no evidence that 3IATLAS is artificial. None. All measurable characteristics so far align with known astrophysical processes. But what surprises me is this: humanity is now technologically mature enough to even evaluate such a hypothesis seriously. A century ago, we lacked the instruments. Today, we can measure tiny deviations in motion. We can detect faint chemical signatures. We can simulate trajectories with extreme accuracy. If 3IATLAS were behaving in a way inconsistent with physics, I would know. And that is the triumph of science. We do not dismiss bold ideas out of fear. We test them. When I calculate its path, I see the elegant mathematics of gravity at work. When I examine its light spectrum, I see familiar chemical fingerprints. When I model its behavior near the sun, I see thermodynamics, not technology. Yet the broader implication remains fascinating. The galaxy is ancient, far older than humanity. If intelligent life has arisen elsewhere, it has had far more time to evolve. That means the possibility of extraterrestrial technology is not absurd. It is statistically plausible. Interstellar objects like 3IATLAS force me to sharpen my analytical tools. They demand precision. Because if one day something truly anomalous appears, something that cannot be explained by gravity, chemistry, or thermodynamics, I must be ready to recognize it. And that readiness is part of scientific maturity. What truly surprises me is not the speculation. It is the shift in perspective. For centuries, we believed our solar system was isolated. Now I know that material flows between stars. The boundary is porous. That alone changes the conversation about extraterrestrial life. Even if 3IATLAS is completely natural, and all evidence suggests it is, it still represents interstellar exchange. And that exchange means the galaxy is interconnected. If intelligent civilizations exist, they too are part of that network. When I look at 3IATLAS, I see a natural object shaped by gravity. But I also see a rehearsal for the future. One day humanity may send its own interstellar probes, small autonomous explorers traveling for thousands of years. To another civilization, such probes might appear as mysterious visitors. In that sense, studying 3IATLAS is also studying ourselves. It prepares us for the moment when we become the senders, not just the receivers. So is it natural? All evidence says yes. But the deeper surprise is this: we now live in an era where that question is scientifically meaningful. And that is a revolutionary moment in human history. This is only fact number 7. Jisr Hamza Khan Ab Main Part 8 Continue Kar Raha Hun. First person Michio Kaku voice main. Cosmic scale imagination or hard physics ki set. The 10 most surprising facts about 3IATLAS Part 8. It reveals the violent chaos of planet formation. When most people imagine a solar system forming, they picture something peaceful. A glowing young star, a smooth rotating disk, planets gently assembling like clockwork. But that image is an illusion. The truth is far more violent. And 3IATLAS is evidence of that violence. When a star is born, it forms inside a turbulent cloud of gas and dust. Gravity pulls material inward, but conservation of angular momentum forces that material into a spinning disk. Within that disk, particles collide. At first they stick together, then they collide harder. Then they shatter, then they merge again. This is not a calm process, it is cosmic demolition. In the early stages of planet formation, countless rocky bodies, some the size of mountains, others the size of moons, crash into one another at tremendous speeds. Giant impacts are common. In fact, Earth itself was likely shaped by a colossal collision with a Mars-sized object, an event that formed our moon. That is the level of chaos I am talking about. Now imagine giant planets forming within that environment. When a planet like Jupiter emerges, its gravity dominates the entire system. It does not politely remain in place. It migrates. It shifts. It destabilizes everything around it. Smaller bodies are flung inward toward the star. Others are slingshotted outward at escape velocity. 3IATLAS is likely the product of such a gravitational catastrophe. Somewhere long ago, a massive planet altered its orbit. In the process, this object was accelerated to extraordinary speeds and expelled permanently from its parent system. That means 3IATLAS is not just a traveler. It is debris from planetary warfare. One of the most surprising facts is this planetary systems may routinely eject enormous amounts of material into interstellar space. Our own solar system likely did the same. Early in its history, gravitational interactions between Jupiter and Saturn may have destabilized entire regions of debris. Trillions of icy bodies could have been cast into the darkness between stars. If that is true for us, it must be true elsewhere. Multiply that process by hundreds of billions of stars in the Milky Way. The result? The galaxy is filled with wandering planetary fragments, rogue asteroids, orphaned comets, even rogue planets, entire worlds drifting without a star. 3IATLAS is a small piece of that vast population. Its existence confirms something profound. Planet formation is inefficient. Not everything becomes a planet. Much of it becomes interstellar debris. And this chaos has another implication. Planetary systems are dynamic, evolving systems. They change over time, orbits shift, resonances form and break, stability is temporary. When I model such systems mathematically, I see patterns of instability emerging naturally from gravitational equations. Tiny differences in initial conditions amplify over millions of years. A slight orbital change can cascade into system-wide rearrangement. This means that 3IATLAS represents a snapshot of that instability. It is the fossil record of a system that once underwent dramatic gravitational upheaval. Perhaps its parent star still exists, unaware that a fragment of its original disk is now passing by another sun. Perhaps that system looks completely different today than when this object was ejected. In a way, 3IATLAS is a message from a younger version of another solar system. It tells me that calm, stable planetary systems like ours may be the survivors, not the norm. Chaos may be universal. And here is what fascinates me most: that same chaos may be necessary for life. Without gravitational disturbances, comets might never deliver water to rocky planets. Without planetary migration, habitable zones might not stabilize. Destruction and creation are intertwined. The violence that ejects objects like 3IATLAS may also be the mechanism that seeds life elsewhere. The universe is not gentle, but it is productive. When I look at 3IATLAS, I see more than a drifting object. I see proof that planetary systems are born in turbulence. That stars are not isolated sculptors of order, they are engines of dynamic change. And in that cosmic storm, fragments like this are thrown into the galaxy. Some wander forever, some collide with distant worlds. Some, like 3IATLAS, briefly cross paths with intelligent observers. And that encounter allows me to glimpse the raw, untamed physics that shapes worlds. This is only fact number 8. When I look at 3IATLAS, I do not just see the past, I see the future. Because this object represents something larger than astronomy, it represents transition. For thousands of years, humanity looked at the stars as distant lights. My ancestors imagined myths. Later, astronomers mapped constellations. Then we discovered planets, then galaxies. Each step expanded our horizon. Now, for the first time, I am not just observing distant star systems through light. I am detecting physical fragments from them. That is a civilizational milestone. It tells me that humanity is crossing a threshold from planetary species to cosmic participant. 3IATLAS is not extraordinary because it exists. It is extraordinary because we can detect it. Detection requires technology, technology requires science, science requires civilization. This means we have reached a stage in our development where the universe is beginning to open itself to us in new ways. And that realization forces me to ask a deeper question. If interstellar objects can travel between stars naturally, can we? The laws of physics do not forbid interstellar travel. They make it difficult, yes, but not impossible. If a small chunk of rock can drift across the galaxy for millions of years, then an advanced civilization could, in principle, engineer probes that do the same, only faster and with purpose. 3IATLAS is proof that interstellar trajectories are real. The distances are vast. The timescales are immense. But the pathways exist. Gravity connects star systems. The Milky Way is not a collection of isolated islands, it is a network. And one day, I believe humanity will enter that network intentionally. We are already taking the first steps: reusable rockets, private space exploration, advanced propulsion research, laser sail concepts, nuclear propulsion experiments. Each breakthrough shortens the gap between imagination and engineering. 3IATLAS serves as a reminder that interstellar motion is not fantasy, it is physics, and physics is predictable. When I run the equations for future propulsion systems, I see possibilities, not tomorrow, not next year, but within centuries, perhaps even sooner. Small probes traveling to nearby stars, not generation ships, not science fiction cruisers, but intelligent, lightweight explorers, artificial interstellar objects. And here is the profound symmetry. Just as 3IATLAS may be a fragment expelled from another system, one day humanity may expel its own artifacts into the galaxy. Probes carrying our data, our mathematics, our history, our music drifting for millions of years, perhaps passing another young civilization just as ours detects 3IATLAS today. That thought humbles me, because it means we are not merely observers of cosmic processes, we are becoming participants in them. For billions of years, only gravity shaped interstellar exchange. Soon, intelligence will shape it too. 3IATLAS is like a mirror. It shows me what nature has been doing for eons, and it hints at what we might do intentionally. The most surprising implication is this: the galaxy may already contain artificial objects from civilizations older than ours. If we are beginning to consider interstellar probes after only a few centuries of industrial development, what might a civilization millions of years older have achieved? I do not claim that 3IATLAS is artificial. All evidence suggests it is natural. But its existence makes me realize something profound: interstellar travel is not forbidden. It is simply challenging, and humanity has a history of overcoming challenges once thought impossible. Flight was impossible, then it wasn't. Landing on the moon was impossible, then it wasn't. Detecting gravitational waves was impossible, then it wasn't. The trajectory is clear. Step by step, we push outward. 3IATLAS is a milestone marker on that journey. It tells me that the galaxy is accessible, not easily, but physically. The pathways exist. The mathematics works, the engineering challenges are solvable. And that realization changes how I see our destiny. We are not confined to Earth forever. We are not destined to remain a single planet species. We are at the very beginning of a cosmic adolescence. And objects like 3IATLAS are the first whispers from the wider galactic community. Not in language, but in physics. They are reminders that the stars are not unreachable. They are simply waiting. This is only fact number 9. Ji Sir Hamza Khan Ab Main Part 10 Final Part Complete Kar Raha Hoon. First person Michio Kaku Voice Main Philosophical Cosmic Mind Expanding Closure Kisath. 10 Most Surprising Facts About 3IATLAS Part 10 The Ultimate Cosmic Perspective. When I step back and observe 3IATLAS, I am confronted with the immensity of the cosmos. This is not just about an object drifting through space. It is about perspective. Our daily lives are so small, so fleeting, that it is easy to forget the vastness in which we exist. But 3IATLAS reminds me we are temporary inhabitants on a tiny rock orbiting an ordinary star. We are part of a galaxy with hundreds of billions of stars. And each of those stars may have planets, moons, and wandering debris, perhaps even life. I realize that this object, traveling alone for millions or billions of years, embodies the patience and scale of the universe. It has no urgency, no awareness, no goal. Yet its path intersects with our perception for a brief instant. That fleeting encounter is enough to expand my mind, to challenge my assumptions, to rewrite what I consider possible. One of the most surprising facts is this: the universe is both immense and interconnected. Every object has a history. Every fragment carries a story. Every interstellar traveler, whether a rock, a comet, or potentially a probe, is part of a vast narrative spanning billions of years. And humanity is only beginning to read that narrative. 3IATLAS forces me to confront my own insignificance, yet it also inspires humility and ambition simultaneously. Because if a simple rock can traverse the galaxy, then human ingenuity, guided by mathematics, physics, and imagination, can one day cross the stars intentionally. It also reminds me of continuity. Atoms cycle through stars, planets, comets, and life. I am made of stardust. This object is made of stardust. Its journey through space is, in some sense, a reflection of my own origin. When I trace its trajectory through the solar system, I am reminded that we exist within a cosmic ecosystem. Gravity, radiation, chemistry, all interconnected. Nothing is isolated. Nothing is static, and that is the ultimate lesson 3IATLAS teaches me. The universe is dynamic. It is eternal, it is patient. It allows me, a human being on a tiny planet, to glimpse processes that unfold over billions of years. It forces me to think in time scales far beyond human experience. It forces me to expand my imagination. It forces me to become a true citizen of the cosmos, one who recognizes that humanity is part of something far greater than ourselves. Every new interstellar object, every new observation, Every calculation brings me closer to that understanding. 3IATLAS is not just a comet. It is a teacher. It is a messenger from another solar system. It is a reminder that the universe is stranger, larger, and more beautiful than I ever imagined. And as I conclude my reflections, I realize we are witnessing the opening of a new era. An era where humanity no longer just observes the universe. We begin to interact with it. We begin to learn from it in new ways. We begin to understand our place in a galaxy teeming with motion, energy, and potential. 3IATLAS has crossed billions of kilometers of darkness to meet our gaze. And in that encounter, it has changed the way I see everything. Because in the vastness of the cosmos, perspective is the most precious gift of all. This is fact number 10.